This question, consider the situation of block pulley arrangement as shown in this figure. The motor M is fitted to it and string is wound on it according to the arrangement shown in the figure. Given that the string is winding on the shaft at a motor at a speed of V, find the speed with which the plank would be going up. Okay, so this is a motor and it is winding the string. So the entire string can be broadly divided into two parts. In the first part, we can say the string is from, let us call this as point A, and it will be starting from point A up till this Y pulley, and the second string will be, let us call this as point C, and this is E, and the second string goes from C and up till the motor M. So this entire discussion will be carried based on this figure. So let us assume that the string 1 with the plank A moves up by a distance AB. Okay, so we can write this one. The entire setup consists of two strings which are string 1 and string 2. Okay, and let us assume that string 1 moves a distance of x. This means that AB is equal to x. So this is the first part. The distance AB is the moment of the string 1 which is given as x. So because of this moment, what happens? The pulley Y will be coming in the down direction. We can say that because of this movement of plank, pulley Y will be moving in downward direction, with a downward direction with the distance x. Okay, the pulley Y will move in this direction with x. Okay, and because of the movement of pulley Y in downward direction from initial position of GI, it will be coming in new position to HJ. So we can say that distance GH will be x and IJ will be also equal to x. So the initial slack in the string 2 and there is, as plank A move in upward direction, there is additional slack of CD which is also equal to X. Okay, because of upward movement of plank, there is additional slack DC which is also X. So we can say that the total slack, therefore the total slack in string 2 due to GH, IJ and CD will be equal to X plus X, that will be equal to 3X. But as the plank moves upward direction, the pulley Z also moves up by a distance EF, that is equal to X. Okay, but due to upward motion of plank, pulley Z moves a distance EF which is equal to X. Okay, so this further produces slack in string 2 which is given by KL and MN. Each is equal to X. So the total slack, thus the total slack in string 2 will be the addition of 3, we already calculated 3X plus KL plus MN, and this will be equal to 3X plus X and plus X, which will be coming as 5X. Okay, now in the last part, the motor also moves a distance X in upward direction. So you can say that thus the total slack will be equal to 5x plus x. This will equal to 6x. Now it is given that the velocity of the motor winding, it is given that the winding speed of motor is equal to v. And secondly, motor speed or the winding speed of motor is given as v, and we can say if the plank moves a distance x in the forward direction, the string wound by the motor should cover the length is equal to 6 times x. Thus we can say the speed with which the plank goes up will be equal to, in terms of v we can easily calculate it, and that will be coming as equal to v by 6, which will be equal to v by 6. So this is the final answer. So basically it means in the first case we said that the plank rises by a distance AB which is equal to x, and y, the entire pulley will be moving in downward direction x, and this will give rise to a distance on the left side of the pulley y by x, as well as on the right side it will be coming as x. So it will be x and total will be coming as 3x. Now secondly, as the plank rises upward, DC x will produce additional slack in the pulley y, so we are going to get this entire will be equal to now 3x. Okay, so this will be x plus x and 1 plus here, then it will be coming as 3x. And further, as the plank move upward, EF will be also x. This will be giving Z pulley by upward in Z direct upward by distance x. We can say that there will be additional slack of KL as well as MN, where each equal to x, and the entire will be coming as 5x. And finally, without the motor rotating or winding, it will be rising by a distance x. So this will be 5 plus x, so it will be coming as the total slack will be coming as 6x. So based on this, you can clearly see that the winding speed of the motor should be coming as v by 6, as the total distance, or we can say total length which the motor should be winding is equal to 6x. Total coming winding 6x, and motor speed is v, so plank should be rising with a speed of v by 6, so that there is no slack in the entire as well as string 1 as well as string 2. Thank you.